Have you ever wondered how deeply connected you are to your mothers? Not just emotionally, but also at a cellular level, even after birth. Imagine carrying millions of your mother's cells inside you, influencing your health in ways we're just starting to understand. It is well established that during pregnancy, there's an exchange of cells between the mother and the baby through the placenta. And this phenomena is called maternal microchimerism. But this transfer of cells doesn't just stop after pregnancy. It actually continues through breastfeeding, which is a new concept we're just beginning to explore. Breast milk is more than just nutrition. It is a source of vital immune cells and compounds that help build the immunity of the newborn. Among these immune cells are regulatory T cells, or Tregs, which are known to be the peacekeepers of the immune system as they help in reducing inflammation as well as lowering the risk of autoimmune diseases and allergies. From our previous work, we've established that breastfed babies have nearly twice as many Tregs in comparison to formula-fed babies by just 3 weeks of age. Yet, the big question remains, are these Tregs being produced within the baby? Or are they being transferred through the mother via breastfeeding? And this is where my groundbreaking research comes into action, where we're trying to investigate how maternal microchimerism through breastfeeding could be a key in establishing a strong immune foundation from birth. By using advanced animal models, human samples, we can now track how these Tregs are being transferred from the breast milk in the newborns. Not only that, we can also see how these Tregs might be changing in function as they integrate into the newborn's organs and blood, influencing their overall immune health. Our work has the potential to revolutionize neonatal care by providing new therapies to ensure that every baby starts their life with a robust immune system. Our discovery also enhances our understanding of early life immunity, paving the way for a healthier future for every child. So let's break down the walls of early immunity to build a stronger foundation for tomorrow. Thank you.
Kia ora, Shalini. Any questions for Shalini?
Kia ora. So, sounds really interesting. It sounds like you've got a fluorescent mouse.
Yes, we do.
Awesome. I've always wanted one. The fluorescent mouse is producing the offspring, or are you transferring the offspring to a fluorescent mouse? That must be what you're doing.
Yes, so the question, the answer is, that this mouse is actually the cells that we're looking at, Tregs. They are the ones that are tagged with the fluorescent marker. So all the cells are left as it is. It's just those Tregs that are glowing. So we're using this fluorescent mouse, or the mother, and then we breastfeed pups that don't have this fluorescent marker. So if Tregs are being transferred to the pups, we can then look into the organs and the blood of the pups and actually tag where this fluorescent marker is and see where these Tregs are localized. Yeah.
Can you elaborate just a little bit more on how this discovery can translate to new therapeutics?
New therapeutics? Yeah, sure. So this is obviously a preliminary study at the moment. Obviously, have to build a lot on it. But Tregs are quite essential. They play, like I said, they're the peacekeepers of the immune system. And when the baby is born, they're like an empty, like a new computer with no antivirus, nothing. So what we can do is, by using this model, we can see these changes that are happening in the Tregs. We can apply this model into a disease model, for instance, for babies, and see how these Tregs are changing, what sort of molecular changes are happening in these Tregs. And if we can target that specific molecule, we can then take that into clinic and actually make medications out of it, which can either be given to the mother, so when they breastfeed, that's gone through the breast milk to the baby, or it's given to the baby through that.